All right, hello and welcome back. My name is Cameron Kirk, and this is my series of videos on how to develop in Verilog and also how to program and work with the DE10 Nano, primarily the FPGA and working with Quartus. In this video, though, I don't think we're going to be programming the DE10 Nano. We're going to be looking at a couple of examples to help you get used to the Verilog syntax and get used to working with and writing with the code and making sure you understand it. So let me get out of the way here. And I have a couple of examples ready to go. So I'm going to use Visual Studio Code. This is just basically a text editor. So if you're not familiar with it, don't be alarmed. I'm just opening it as a text file. So this is our code from the previous video, and what we have here is a AND gate with two inputs, and it's in a module, and it has an output called Y and an input called B and A, and we're going to do this continuous assignment statement to write out the Boolean equation of an AND gate. And this is great because then in let's say like we're using this as like a small component in our overall giant Verilog design, and so we can use this component in another module elsewhere. We can say something like and2_v, and I'll just call this A1 as the name, and then I'll feed it in, I don't know, some wires, so T3, T1, T2. We haven't seen this yet, but basically what's going to be happening, this is just an example, we're going to have these as our inputs, and this is our output. It'll make more sense in a second once we start to see what primitives are, and that is the topic of this video. So two things I want to comment here about this code. First of all, doing like an AND gate, for example, is just such a common thing. Like, it is so common that they already have an AND gate module defined for you as a built-in primitive in the language. So rather than us writing out this equation, I mean, it's perfectly fine to do this. An equivalent thing would be to use the AND gate primitive. And the way we would do that is we would say and space, and then we have to give it a name. And then we're going to give it, you know, our output first, and then our inputs, like that. And that is all there is to it. Now, I believe it is also optional to give it a name, so you could leave it like that. Either way works. And this is equivalent. Yeah. So we're not going to spend too much time here. I'm going to put these all back and save that. Okay, so that brings me to my next example and what we're going to be doing in this video. So I have this second Verilog file up here. Let's take a look at that. And here's a module I've called F1, and I've given it some outputs right here, X and Y, and I've given it some inputs, and I've called my inputs SW1, SW2, SW3. I was thinking maybe these could be switches. It doesn't really matter. So everything's looking great. Now here's something that's new. I have defined something called a wire. So notice this is not in our port listing at the top here. This is yeah, it's nice. It's, you know, think of like just here. Let's draw this out just to make sure it's really clear what I'm trying to say. So when we define our module, we have this box, right? And we can define our outputs, and we can define our inputs. And then what's inside the box, we don't really know, and we don't really need to tell other people who want to use this box to use its function. We don't need to tell them what's inside. But we do need ways of, you know, moving lines of information around inside our module, and that is why we have the type called wire. Cool. That was a terrible drawing, but I hope you get the idea. Let me just check my notes if there's anything else to say about wires. Yeah, that's pretty much the gist of it. Let's keep going. So now you're going to start to see some of these built-in primitives that I'm using here, and I've given them all instance names. So I've called my XOR gate X1, I called my NOT gate N1, and A1, and OR O1. And the convention here is this XOR gate takes two inputs and it has one output. It's going to XOR these two lines and put it on an output. And in this output, I've specified my wire. And yeah, that's pretty much it. So the convention is, I need to make sure that's how you do a comment. Okay. The convention is in your port list, you're going to have your output and then your input. And I'll put S inside parentheses because there could be more than one input. So always output first and then your inputs. And that's how you use these primitives. Cool. So with all of that said, let's now jump over to Quartus, and we're going to make the block diagram that implements what is described in this Verilog code. So I already have an empty project started up. We're not going to actually get to the part where we program this onto the board in this video. I don't think it's necessary. This is more for understanding purposes. So I have here, I already dropped it an output and I have an input already. Can we make this font size bigger? Maybe I can zoom in some more. Okay, that's good. All right, so let's take a look at that code. We have, let's do our inputs first. We have S1, S2, S3. So let's get this guy, and we're going to duplicate him. Copy, paste, paste. Great. What? I don't know what happened there. All right. So this guy can be our SW1. This guy can be our SW2. And this guy can be our SW3. Great. And then we have our outputs. What are our outputs? X and Y. So we need another output. I'll just copy. Actually, I'll get it from up here. This button right here, you get an output. Just in case if you haven't seen that before. So there's an output. I'm going to get back to the regular tool. This guy can be our X. I'll do lowercase x. And this guy can be our Y. Okay, so far we have covered these two lines of code. We're not going to do the wires yet, but when it says it's going to go on a wire, we're going to put it on a wire. So the first primitive we see is an XOR gate, two input XOR gate. So I'm going to click on the gates button, and that is going to open up this window called symbol. And I'm going to type in XOR. There it is. Click OK. And we can drop this guy in. Oh, these are A and B. I guess I was not paying attention to what I was doing. Sorry about that. SW3. SW2. All right, so now this code makes sense. I didn't catch that when I wrote that originally. Oh well, it's fixed now. Okay, let's keep going. So we're going to take SW1 and SW2 and XOR them together and put them on T1. So what did I just say? SW1, SW2, and then that'll be T1. So I'll just put it right there. And I think this guy, yeah, the text tool, we're going to call that T1. Okay. What's next? So now we have all of this code done. We're going to need a NOT gate, and we're going to NOT T1. NOT T1 and put it on X. All right, so let's get our gate. We need a NOT gate. There it is. We'll drop it right there. We're going to NOT T1 and drop it in on X. There we go. This is looking good. So now we have implemented all of these lines of code. Let's get this AND gate. So that's a 2-input AND gate. Let me get the symbol window up. We're going to type in AND 2. There it is. Click OK. I'm going to put it right there. And I think we're going to have to do a little loop back, right? Because the input for our AND gate is an X. So in order to get the X, we're just going to grab this wire here. And do I like it like that? Yes, this will be fine. And there it is. So we just tapped into our little X wire right there and wrapped it back around and dropped it into the input. The other thing it wants is an SW3. So we're going to do SW3 as an input, and this goes to Y, correct? No, this goes to T2. All right, so we're going to make the wire poke out. We're going to get the text tool. It's not necessary to put the text tool on there, T2, but I'm just doing it for absolute clarity. And then from T2, we're sending it to an OR gate. Okay, so let's get the OR gate out here. OR 2. There he is. And do I want to? Yeah, let's move this guy. Let's just move this guy over here, right in front of the OR gate. The OR gate is getting T2 and SW2. So T2, actually it was a good thing I put labels on this because this is getting crazy. T2 is going to the input, and SW2, which I believe is the second guy right here. Yeah, SW2. We got both of those inputs to the OR gate, and now we're going to send it to the output. Double check on that. Send it to the output, that's right. And this is the entire Verilog code implemented as a block diagram using primitives. So hopefully it's pretty clear. These are just some of the primitives that Verilog allows you to use in your code. I tried to look for a complete list, but after a quick Google search, I didn't find a helpful resource. But if you happen to find something, feel free to share in the comments that it's over here or over there, and I will link that in future videos. But regardless, I don't think it's too important. This is enough to get you started with using primitives. These are pretty common primitives to use. And yeah, so let's save this block diagram. I'm going to do file save as. Oops, I did save project. Oh, well, let's save the changes. Save as on this block diagram, and I have named this block diagram the same name as my project because it's the top level entity. Cool. No, don't need to replace it. Next up, we are going to do the analysis and elaboration. So I'll let that go. And then we're just going to do the waveform. And then after we do the waveform and we see the results, we're going to do one more example, which is going to be from a block diagram to Verilog code using primitives. So we're going to go the other direction. We've seen how to do it from code to block diagram. Now we're going to go from block diagram to code. And then, of course, we'll do the waveform, and then we will finish it out. Let me double check my notes that is, yeah, that's the plan. Cool. So I believe I already have a waveform. Let me click open. Where is it? I don't see it. I guess I will make another waveform. All files. Oh, here it is. University waveform. Click open. Okay, here it is. These guys are not inputs anymore. Delete those. We're gonna right click. So in order to get this waveform, if you haven't done it in your project yet, you go to File, New, and then it is the University Program VWF. I've shown that in a previous video, but just in case. So here it is. We're going to right click in this blank area, click Insert Node or Bus. We're going to click on Node Finder. We're going to click List. We're going to click this double greater than sign. Bring them all over. Click OK. Click OK. And then for SW1, I am going to apply a counter, and it will be every 100 nanoseconds it will increment. The SW2, I'm going to apply a counter. This will be every 200 nanoseconds. I'm doing powers of 2. And then the SW3, it will be every 400 nanoseconds. And now you can see we have every possible combination of the switches. Let's click play. Save the changes, yes. Let that load. We didn't get our outputs. What happened? Let me pause the recording and investigate what happened. Okay, I'm back. I had clicked on this play, back on Quartus, before I opened the waveform. I clicked on Start Analysis and Elaboration, and what I meant to click on was Start Analysis and Synthesis. And then after you do this analysis and synthesis, I just went back to the waveform and I closed the output from last time, and I went back to this one, the editor, and I clicked the play button here, Run Functional Simulation, clicked on that, and then this popped up just like last time, but then this time it actually worked, and this time it actually gave me the waveform. So we can observe that. Looks good. Now we could spend the time doing the truth table, and we could actually validate that this is what it's supposed to be doing. But this is where you would go to actually simulate it and verify that. So we're not going to do that in this video. We're going to keep going. Great. So let me pause the recording and set up the next example. Yeah, give me 1 second. Okay, we're back. I have here example 2. Let me cancel on that. Example 2. This is a block diagram I put together while it was paused. And I'm going to go up here to File, New. And then our original top-level entity, I saved it as example 1. And then I went ahead and I right-clicked on this, and I went to Settings. And then I removed the top-level entity that was the block diagram schematic file, and then I clicked OK. So now what we're going to do is we're going to say File, New, and we're going to add a Verilog HDL file. And here it is. And we're going to write our code in here. So just to speed things along, I'm going to come back to this F1 module. I'm going to copy this guy. And I will paste it in here. And you know what? Since I've done that, why don't we try DE10 vid. Why don't we try getting the waveform for the F1 module? I should have taken a screenshot of the block diagram waveform, and then we could have compared it with the waveform from this guy. Decisions. No, I'm going to stick to the plan. It wasn't my original plan to make the waveform for this guy, so we're not gonna do that at this time. But I guess we could check that analysis and synthesis works. So let's try that. Make sure we don't get any errors. I'm being indecisive. You know what? It really won't be too much trouble to just go ahead and get the waveform. Yeah. Let me pause the recording while this loads. Oh, actually, it's about to be done. Okay, it's done. Let's do that waveform. So File, Open. We can change this guy to all. Yeah, it's already on all files. We're going to get the waveform. We're going to delete these guys. They're from the last one. We're going to do Insert Node or Bus, Node Finder, List, put them all in there, click OK. Click OK. X and Y and out. X and Y and out. X and Y. I don't think that's the top level entity. Okay, let me pause the recording and find. I know I've done it before. Where to change the top level entity? Hold on. Okay, I'm back. So if we go into settings, we pick DE10 Nano. We move it up, up, up. I don't remember doing this, but I think maybe that's how you do it. So let's try again. We're going to do analysis and synthesis. We're going to not save the changes to the waveform. Let this load. And I'm going to pause the recording while it loads. Okay, so that finished. Let's go back to the waveform. These are not our nodes that we want, so I'm going to delete those. Insert, Node Finder, List, X and Y and output. How did it get that? Darn it. Cancel. I know there's a way to do it. Don't cancel. Just wait there. Oh my goodness. Settings. Top level entity. Properties. That is the top level entity. Top level entity is the DE10 Nano. Click OK. Click OK. DE10. Oh, wait a second. Settings. Top there. Okay, so this is where you change it. DE10 Nano. But I think that is. Oh. We want it to be F1. Click OK. Click OK. Because F1 is the name of this module right here. Click Start Analysis and Synthesis. Don't save the changes. You know, I never know when I make mistakes like this and then I spend time figuring it out. I never know when is it worthwhile to leave the camera recording, because it will help viewers like you know how to approach these problems whenever you get a roadblock, and it's only up to you to make it to work. I feel like sometimes it does provide value for me to show the process I go through when I troubleshoot and debug just weird things like that. But then other times, I feel like in other video series or in this video series, I get stuck and then I leave it recording. And I'm like, oh man, I hope I'm not wasting my viewers' time. I'm hoping that they're interested in what I'm talking about. But if you're watching this part, let me know in the comments if you appreciate being able to see how I fix those types of problems. Anyways, okay, that finished and doing the analysis. Let's come back in here. We'll just close it. Close it. Don't save. Let's open it again. Let's open that waveform. All right, we don't want any of these nodes because they are not actually what we're looking for. List. This is correct. This is correct. This is correct. because in our Verilog, that is our port list. Okay, good. So yeah, it may or may not have been worth the time going through this, but it's going to be the exact same as what we did from the block diagram. So I will do this very quickly, and then we will move on. Click play, save the changes. Darn it. Oh, I think it's the analysis and synthesis. So let's stop this. Click on, I thought I did do that. F1 is the top level entity. DE10, F1. Okay, I may give up on this if it doesn't work this time. It's going to be the same. Really? Man, why is it don't care? I don't know how that happens. All right. Let me pause the recording and figure out why. Okay, I finally got the waveform. I think unfortunately I've just never had any luck with having multiple modules in one Cordis project and then switching around the top level entity. Usually I find I have the best luck when I set this guy as the top level entity and I never bother changing it because I just have the worst luck. So in order to get this waveform, what I had to do was I had to go ahead and make a new Cordis project and set all that up and then put in a new Verilog file and then do the waveform again. And now it works and it looks like it is the exact same as the block diagram. So feel free to not follow along if you were trying to. You don't have to actually go through with this step. But if you want good practice, it's good practice. Anyways, let's get to what I really want to do, which is write Verilog code. We'll just minimize that. Write Verilog code using primitives that implements the block diagram. Oh boy. The block diagram from this guy. So we have two inputs and an output. So let's go ahead and add that to our Verilog code. And I think I can make this font size larger. View. What is this? Find. Indent. Show line numbers. Toggle comment. Let's just do it this way. Let's not do it that way. Darn. Let's do it this way. The good old magnifier. No? No magnifier? Oh, there it is. So we'll just put that guy right there. Okay. Yes. This is looking good. Can we switch this? We cannot. Okay. So There we go. All right, so we have X and Y, and we have an output. All right, forget this. Let's get this guy. Oh, yeah, we have an out, X, Y, and out. All right. X, Y, and out. Our inputs are X and Y. So let's just put out right here. Shift, cut, paste, shift, delete. Okay, that looks good. And then we're gonna need a couple of wires coming out of the NOT gates to hold the NOT value. So 2 wires, maybe 2 more wires for the AND gates. Yeah, so a total of 4 wires. Yeah, 4 wires. So we're gonna do this wire coming out of this NOT gate, this wire coming out of this NOT gate, and then this wire and this wire. All right, I don't think it likes me using this magnifier. Let's just ditch that. Cool. So we'll come back over here. We need 2 more wires, so we'll do T3 and T4. Okay. We need 2 NOT gates. So let's move all that down. So NOT gate, so there's NOT 1 and NOT 2. And the input, the output will be T1. Remember, output comes first. The input will be X. The output will be T2, and the input will be Y. Okay. Now we need 2 AND gates. So AND gate, AND gate. And the first AND gate will take T2, and it'll take X. So X and T2. And it will go on to T3. And the next one will make T4, and it will take Y, and it will take T1. Because T1 is not Y. T1. Ah! T1. Oh, T1 is not X. T1 is not X. So we want not X and we want Y. So Y, not X. You know what? It would just be simpler if we just called this not underscore X, and we called this not underscore Y. So we're going to call this wire not X. We're going to call this wire not Y. And not X was T1. Okay, like that. So now we have X to make not X, Y to make not Y. We put it in the NOT gate. Then we take X and not Y, and we take Y and not X. We put it on T3 and T4. And so finally, I believe we need an OR gate. Yep, finally is an OR gate right there, which will take T3 and T4 and put it on the out. So here is our OR gate, which takes T3 and T4. And we put it on the output pin. The rest of this we can delete. And that's it. So we have just implemented this schematic. I'm going to use Control and the scroll wheel to zoom out. So yeah, this is the schematic we just implemented in Verilog. So here's the Verilog code. And honestly, typing out this Verilog code is, as you can see, much easier than clicking on the little symbol tool, finding our symbol, clicking it there, dragging the wires, all of that. Oh, forget about it. This is a much simpler way of making those types of circuits. And we have made this simple little module. We're calling it the F1 module. So let's do our analysis and synthesis. I will click that button. I'm going to pause the recording while that loads. Okay, so it threw an error. I'm back. It threw an error and it's complaining about something I typed. So clearly oh, yeah, I see it. It's the curse of the copy and paste. So, man, I really wish, okay, I'm going to cheat a little bit. I really want that font size to be bigger. So here's our code. There's our code. Next time I will have a scene set up for this, so I don't have to do that live. But anyways, here is our code. And because I copied and pasted, the instance name has to be unique, and it's saying I already declared it. So I will fix that mistake, and I will start the analysis and synthesis again, and I will pause the recording and put everything back. Okay, we're back, and this time it was successful. So let's go ahead and open up. Oh, maybe I still have it open. No, I don't have it open anymore. I'm going to go to File, Open. I want that waveform back. We're going to change it to all types of files. We're going to click on Waveform. There is our waveform. We don't want these nodes, so let's delete them. We're going to right-click in this blank area on the bar on the left, go to Insert Node or Bus, click on Node Finder. We're going to list them all out, and this is correct. X, Y input, out is our output. Bring them all over with the greater than sign. Click OK, click OK. We're going to click the functional simulation. Yes, save the changes and let this load. This shouldn't take too long to load. And we should see, oh, you know what I forgot? I forgot to apply a counter to the inputs. So let's close this down. Let's pick our X. We're going to do a counter. We're going to do every 100 nanoseconds. And for our Y, we're going to do a power of 2, so every 200 nanoseconds. And there we go. We have every combination of X and Y. We're going to hit the Run Functional, click Yes. Yes to save it. And this should be the final thing once we see this waveform, right? Okay, there it is. So our out, yeah, this should be an exclusive OR. So this is implementing the equivalent of an exclusive OR. And when we look at our waveform, when we have X or when we have Y, but not both and not neither, our output will be high, and that is an exclusive OR. So that is everything for this video. I hope this was helpful for you. Sorry I got lost in the middle there trying to figure out the whole top level entity thing. I guess the lesson learned there is it is a huge headache if you try to on the fly change your top level entity. I've never been good at it, and I've always found it to be much easier to just make another project, as painful as that is. There's no if you happen to know of an easy way to change the top level entity, please let me know in the comments section, and I would be happy to absorb that knowledge from you. But in any case, thanks for watching, and I will see you in the next one. Take care. Bye-bye.